Quadratic functions have several different characteristics. They're the same characteristics you learned about when you were doing linear and exponential functions last year. You've got your domain and range. Your zeros are also known as your x-intercepts, where it crosses the x-axis. Your y-intercepts, where it crosses the y-axis. Extrema is where it comes to a peak or a valley. Interval of increase is the part of the graph that's rising as you read it from left to right. Interval of decrease is the part of the graph that's falling as you read it to left to right. A parabola or a quadratic function will have an axis of symmetry. That's a line that goes straight through the vertex of the parabola at x equals h, and it cuts the parabola in half. And then you have the vertex, which is the point that the graph changes direction. So looking at these two graphs, we're going to do the first one here, and then we'll do the second one below. So looking at the first graph, which is in black, your domain goes from negative infinity to positive infinity because it's going to keep going left forever and it's going to keep going right forever. Your range, the lowest point that this graph is ever going to go is at positive 1, and it's going to go to infinity as both ends are going up forever. It will not cross the x-axis ever, so there are no zeros or x-intercepts. The y-intercept is where I look at my y-axis and see where does it touch, and it touches right here at positive 5. Your extrema is your valley. So this is a minimum value right here at this point on this graph, and it's at the point 2, 1. That is a minimum at 2, 1. So you're going to need to make sure you identify what kind of extrema it is. Interval of increase. So as I'm reading from left to right, starting here and moving in this direction, the graph is increasing at all times. So your interval of increase starts at 1 and goes up to positive infinity. Your interval of decrease, well, from negative infinity all the way to this point, it's decreasing the whole time. As I'm reading it from left to right, it's going down. So your interval of increase is from negative infinity to 1. Your axis of symmetry is this vertical line that cuts the graph in half. This is a vertical line at x equals 2. And then your vertex is the point where it changes direction. So we're going negative, we're going in a decreasing pattern, and then we stop here and turn around and go back to increasing again. Out of all of these, your vertex and axis of symmetry will be the easiest to remember. Typically the hardest parts to get are the interval of increase and decrease. What you've got to look at though is if you take a look at your domain, you're splitting your domain in half at the x value in your range. Okay? Or excuse me. Yes, you're splitting the domain in half at the x value of your vertex, which means your interval of increase actually needs to start at 2. Pardon me for messing that up. And go into 2 in this one here. So it splits your domain at the x value of your vertex. Splits the domain at the x value of the vertex. One side will be increasing and the other will be decreasing. Both of these examples have the decreasing first, so it's negative infinity to 2, and then from 2 to positive infinity. So let's take a look at the pink one to make sure I got it right. So your domain would be negative infinity to positive infinity. Spell domain correctly. It's going to be a mistake somewhere. For all quadratics, it's going to be negative infinity to positive infinity. Anything that's pointing up, that both ends are going up or both ends are going down, is going to be negative infinity to positive infinity. Your range is going to be, the lowest point it'll go is at negative 4, so negative 4 to positive infinity. It'll cross the x-axis at both x equals 0 and x equals 4. Your y-intercept is where it crosses the y-axis, which would be at y equals 0. This has a little valley down here, meaning it's going to have a minimum rather than a maximum. And that valley point is at your vertex, which, take a look there, your minimum point up here was at your vertex. It matches. So minimums and maximums of quadratics will always be at the exact same point of your vertex. So this is a minimum at the negative 2, negative 4. Interval of increase and decrease, I did get it right. It's the x value of your vertex, but it splits your domain in half. So negative infinity to my x value is a decreasing area, and then it starts increasing at negative 2 and goes to infinity. Then your axis of symmetry is at the x value of your vertex. So as you're doing these, if you get a list and vertex is at the bottom, it's okay to go fill in that one first, because obviously you can use this for your extrema. You can use the x value for your axis of symmetry. You can use the x value to figure out your intervals of increase and decrease. So I wrote in here this note, notice the similarity of all the answers. Are they connected so that we can use some to figure out others if you get stuck? So if you take a look at your domain, your range, take a look at where your range starts and the y value of your vertex. Your zeros and y-intercepts aren't really totally connected. This is a fluke that happens to be at x equals -4. However, your extrema and your vertex are very closely related. Your axis of symmetry and your intervals of increase and decrease all are connected to this x value of your vertex.